Okay, dear friends and students. So actually, this series of clips will be how we can use MS Excel and some other tools for compilation of data, preparation of table and figures, and later on probably we'll use R and other softwares for the analysis for the data which is generated actually in the agriculture experiments. And that will be basically how I use it actually. So that there could be some other smarter ways or some more efficient ways, but this is how I do, and I would like to share with my students and my friends. So what's actually important that in case of agriculture experiments, we are doing different experimentations, and then we have data on different parameters like plant height, spike length, number of seeds per spike, etc. The disease data, we would like to see its different ranges like minimum, maximum, mean, standard deviation. So you would like to have such tables for your thesis or paper or whatever you want to present. You may also like to have like the different genotypes and then how they behave in terms of different parameters. You would like to show it on figures. Now to do this actually, there are different ways, but there are some tools in Excel which you can use. And actually Excel is not made for arranging the data and storing the data. So the first thing I used to do is actually I organize the data in Excel. So like I have this experiment, so I just generated this data to give an example, which reflects actually a 3 years experiment actually rather, and three location, different set of germplasm, and then in each germplasm set there are different varieties. So you have the years here, you have the location, then the replication, of course, the different set of germplasm, right? You have, okay, and then you have the different genotypes and then a series of parameters so on which data was taken. So the first thing I used to do is actually either I use this data tool which is like filter, where I would like to see whether my data is expected or there are some problems. So like directly I can see here that there is 2022, 2023, 2024, and then probably when I compile the data or my student compile the data, here we have this y22. So y 2022 is not the same as 2022. So I would like to replace this thing actually to keep it coherent. So these are just smart practices you have to do when you are entering the data. And actually when are using R or different software, so for them it will be completely different things. So the small spaces or tabs or making upper or lower case, it will make a difference. So that was one problem. Then like I can see one by one other ones. So I have three location, they are as expected. I have the replication as expected. Then I can see like, okay, I have different set of germplasm, that's okay, no blank there. Then I have the genotypes, so I have different varieties, there's no problem in it. Then I can also see the data actually. So this is the YR data which is taken on a scale from 0 to 100, so I can see if there's any problem. And I can see there is one data which is 200. Another way to do is actually sometimes, so I sometimes what I do is I will have this. Okay, so I will plot this data, and plotting the data can also clearly give you the idea. So if you click on the insert and then you just take a scatter plot, and you can see that there's a data. So all the data is okay below 100, which is as expected. The severity ranges from 0 to 100%, and then I have a 200 value. And actually, this I can see that this is coming from the problem. So I look back into my lab book and I can see that, of course, I confirm with the lab book that this is because this was a 20, which was there was a typo mistake and became 20. So it was just I intentionally did this to give you an example. Like if I look at 1,000 grain weight data, I intentionally make a bug there as well. So just to give you an idea, so there's a 390, and that is also a possible bug which should be due to the addition of a zero. When you add the data, instead of zero, you instead of enter actually you press the zero, and you have 390. So this once again on the table you can see 390. All the data is there below and up down 40, but you can see there's 50, this 390 or 400. So such kind of data checks are really good if you can do before going to the next level, right? So you can make such kind of checks before going to the next data analysis things, which I will show in the next video. So this is just the basic analysis, the basic checks you must have before going to the final, how to say, the final compilation or making the tables. So I will stop here, and then in the next video I will come with the next analysis.